Sajju sir.
சார் சொல்லுங்க. ஹலோ
குட் ஆஃப்டர்நூன்
சார்.
செல்வமணி சாரை வந்து ஹோஸ்டா மாத்திருங்க.
ஆரே
இல்ல மேம், ஹோஸ்ட் அவங்க தான். சஜ்ஜு சார் தான் ஹோஸ்ட்.
சார் நான் கட் ஆயிடும்.
செல்வமணி சாரை ஹோஸ்டா போட்டுருங்க.
சரி சார்.
கோ ஹோஸ்ட் வந்து டாக்டர் கே கவிதான்னு வருவாங்க பாருங்க, அவங்க கொடுத்துருங்க.
சரி.
இன்னைக்கு ஸ்பீக்கர் கவிதா மேமா?
கே கவிதா V18 வந்து தெரியல, கூப்பிடுறேன் மேம். இஸ் தேர்?
இங்க வந்து தண்ணியே குடிக்க முடியுமா? சொல்ல மாட்டேங்க. அது மட்டும் எனக்கு தெரிஞ்சு சொட்டியே ரொம்ப மோசமா இருக்குன்னு நினைக்கிறேன்.
சஜ்ஜு சார்
சொல்லுங்க சார்.
அதெல்லாம் யூடியூப் லிங்க் சாட்ல போட்டுருது.
ஆமா, அதுதான் லிங்க், யூடியூப் லிங்க்.
வந்தவங்க பார்த்துருக்கோம். மேம் வந்துட்டீங்களா உள்ளார? ஓகே ஓகே, தேங்க்யூ.
சார் சொல்லுங்க.
சார் சொல்லுங்க. செல்வமணி சாரை வந்து ஹோஸ்டா மாத்திருங்க.
ஓகே.
ஆரே இல்ல மேம், ஹோஸ்ட் அவங்க தான்.
மேம் எப்போதுமே ஹோஸ்ட் சிடிசில தான் பாப்பாங்க, நீங்க ஏன் கன்ஃபியூஸ் பண்றீங்க?
செல்வமணி சாரை ஹோஸ்டா போட்டுருங்க.
சிடி ஹோஸ்ட் சிடிசில தான் பாப்பாங்க மேம்.
நீங்களே ஏதாவது டிசேபிள்.
எஃப்சிஏ மேம். ஹலோ
சொல்லுங்க சார்.
சிடிசில தான் எப்போதும் ஹோஸ்ட் பாப்பாங்க மேம். அவங்க லைவ் ஸ்ட்ரீம் பண்ணிட்டு அதை வந்து நம்ம இதுல போட்டுருவாங்க, டிரைவ்ல போட்டுருவாங்க.
ஓகே. அண்ட் ஆல்சோ ரெக்கார்டிங் நீங்க பண்ணிடுங்க. இல்ல ஹோஸ்டா இருந்தா ரெக்கார்ட் பண்ண முடியாது, அதுக்கு தான் சொன்னேன். நீங்க பேசிக்ஸா ரெக்கார்ட் பண்ணாரு, அதனால somebody if they are recording it will be good.
ஜெபசிங் கிட்ட கொடுத்துடலாமா மேம்?
நீங்களும் ஹோஸ்ட் எடுத்துக்கோங்க, you are the coordinator.
இல்ல கோ ஹோஸ்ட் அவங்களுக்கு கொடுக்கணும், அவங்க மாத்திட்டு அவங்க வந்துட்டு இருக்காங்க இப்ப உள்ளார.
ஓகே,
அவங்கள ரெடி பண்ணிட்டு நான்.
சரி.
Kavita ma'am, welcome.
Hello sir. Yeah, thank you sir.
Sajju sir. Sajju sir.
சார் சேஞ்ச் பண்ணியாச்சு.
கவிதா மேம்க்கு கோ ஹோஸ்ட் கொடுங்க, அவங்க பிரசன்ட் பண்ணணும்.
கொடுத்தாச்சு.
ஓகே மேம், உங்களுக்கு கோ ஹோஸ்ட் கொடுத்துறேன் மேம். யூ கேன் பிரசன்ட் தி ஸ்லைட் நவ.
ஓகே சார், ஓகே.
வெயிட் மேம்,
ஷேர் ஸ்கிரீன் வச்சு நான் ஸ்லைட் ஷேர் பண்ணி டிஸ்கஸ் பண்ணிக்கலாம் இல்லையா?
பண்ணிக்கலாம் மேம்.
ஓகே ஓகே சார்.
Shall we start ma'am? Yes ma'am.
Sir.
செல்வமணி சார் இன்னும் டைம் ஆகல. Just no.
Okay. Okay ma'am. Okay.
Let them join. Let everyone join. I will wait for some time. Okay.
சார் சொல்லுங்க மேம் சொல்லுங்க.
அதை வந்து நம்ம இதுல போட்டுருவாங்க, டிரைவ்ல போட்டுருவாங்க.
இதுவரை நீங்க வெப்சைட்ல பாத்தீங்கன்னா
ஓகே ஆல்சோ ரெக்கார்டிங் நீங்க பண்ணிடுங்க. இல்ல போஸ்ட் அந்த ரெக்கார்ட் பண்ண முடியாது.
இல்ல நான் யாருக்காவது சேஞ்ச் பண்ணிடுறேன் மேம். யாருக்காவது ஒரு ஹோஸ்டா சேஞ்ச் பண்ணிடுவேன். ஏதாவது ஒரு ஸ்டாஃப் மேம்.
நீங்களும் ஹோஸ்ட் எடுத்துக்கோங்க. யூ ஆர் தி கோஆர்டினேட்டர். சார் செல்வமணி கொடுத்துருங்க சார் ஹோஸ்டா.
சரி ஓகே.
வந்து உனக்கு இதுல போட்டுருக்கேன், வெப்சைட்ல போட்டுருக்கேன்.
சார் என்ன கோ ஹோஸ்ட் போட வேண்டாம். நீங்க செல்வமணிக்கும் ஜெபசிங்க்கும் கொடுக்கணும்.
சரி ஓகே.
சார் ஹலோ சார்.
சொல்லுங்க சார். சொல்லுங்க சார். சார் சேஞ்ச் பண்ணியாச்சு.
கவிதா மேமுக்கு கோஹோஸ்ட் கொடுங்க, அவங்க பிரசன்ட் பண்ணணும்.
போடுங்க சார். இதுதான பண்ணுங்க ஃபர்ஸ்ட்.
உங்களுக்கு கோஹோஸ்ட் கொடுத்துறேன். கவிதா மேம், கவிதா மேம்.
Yes sir. Yes
Can you
sir.
hear me?
Yes sir. Yes sir.
மேம் நீங்க உங்களுக்கு கோஹோஸ்ட் கொடுத்தாச்சு மேம். நீங்க பிரசன்டேஷனை நீங்க ஸ்லைட் ரெடி பண்ணிக்கங்க.
ஓகேங்க சார். நான் வெரிஃபை பண்ணிக்கவா ஷேர் ஆகுதா இல்லையான்னு?
யா.
ஓகேங்க சார்.
இல்ல இது ஒரு 10 செகண்ட் மாறி தான வருது. அதான் சரி நீ என்ன பண்ணு, யூடியூப்ல அவங்க கேட்ட क्वेश्चन, யூடியூப்ல அவங்க கேட்ட क्वेश्चन வரல, அதுக்கு ஒரு டைம் நீங்க ரிப்ளை பண்ணு நேரா. புரியுதா?
Sir, are you able to see my screen?
Yes ma'am. Full screen போடுங்க.
Oh, full screen. Can I increase the font size? It is in PDF, sir. Is it okay?
Sir, you can give Control L, ma'am. Control L will give full screen.
Okay. Is it okay, ma'am?
Yes. Now you can minimize. After we start, you can talk. Okay?
Okay, okay. Can I stop the sharing, ma'am? Can I stop the slide?
Yeah, no problem, ma'am. It's only title only, no problem.
Okay, ma'am. Okay.
Charge எவ்வளவு இருக்கு? Hello? Yes. Mail post. Let's open it. Sure, ma'am. Sure, ma'am. Sir, start, ma'am. Current இது பவர் கட் போச்சு, கொஞ்சம் குயிக்கா பண்ணிடுங்க. I request Dr. Hepsivam to give some word about this FD.
Good afternoon, every one of you. I welcome you all to the FDP on Applied and Computational Mathematics. Thank you for accepting our invitation and joining in this afternoon. Even in this pandemic time, you're all busy with your own online classes or online examinations, but you took time to enrich your knowledge through all the topics which we have offered. My special thanks to today's speaker, Dr. Kavita ma'am from VIT. Thank you so much, ma'am, for accepting our invitation. I hope this FDP will be beneficial to each and every one of you to enrich your knowledge. Thank you so much. Now I hand over the session to Selvamani sir to introduce the speaker of this day.
Thank you, ma'am. Very good afternoon to all. I feel honored and privileged in welcoming the guest speaker of the day, Dr. K. Kavita, Senior Assistant Professor, School of Advanced Sciences, Department of Mathematics, Vellore Institute of Technology, Vellore. Madam is having rich and novel teaching and research capabilities, both in national and international standards. Her research topic covers mainly operational research, sensitivity analysis, and fuzzy set theory. Sensitivity analysis explores the relation between dependent and independent variables. So it plays a vital role in applied and computation field for accurate forecasting. Now, I requested Dr. Kavita ma'am to start the presentation. Ma'am, you can start now, ma'am.
Okay, sir. Thank you, sir, for your very nice introduction. Yeah. Very good afternoon, one and all. First of all, I'd like to thank Professor Sarvamani for inviting me as a resource person for this online FDP today's session. Okay. So today we'll discuss about that sensitivity analysis and allocation problems. So first we'll focus on what is mean by allocation problems. So in that, assigning the available resources subject to the given restrictions. For example, we consider take the conditions also, that assigning the available resources subject to the conditions in an economical is known as resource allocation. For limited sources of supply and demand, the best planning of allocation to get the maximum return or best plan with the least cost. So whichever may be applicable to the problem is to be found out. So this type of problems are called allocation problems. So this allocation problems can be classified into two categories. That one is assignment problem, that another one is transportation problem. So the main objective of the transportation problem is to determine the shipping schedule that minimizes the total shipping cost while satisfying the conditions. That is, while satisfying the supply and demand limits. So the main objective of the assignment problem is to find an assignment schedule in a job assignment problem where M jobs are allocated to N workers and each worker receives exactly one job, such that the total assignment cost is minimal. So that allocation problem divided into two types. That one is assignment problem, another one is transportation problem. So in that, how to simplify that sensitivity analysis part. That sensitivity analysis, that another name we call it as post-optimality analysis. That sensitivity analysis, another name we call it as post-optimality analysis. What it means, we need to study the problem after finding the optimal solution. Sensitivity analysis, that another name we call it as post-optimality analysis. So once we identify the optimal solution, then we concentrate on sensitivity analysis. That sensitivity analysis provides that sensitivity ranges. For example, we consider that maximum limit, minimum limit. That sensitivity ranges within which the linear programming model parameters can vary without changing the optimality of the current optimal solution. So once we identify the optimal solution, we won't change the particular optimal solution. Without affecting the current optimal solution, we want to identify the sensitivity ranges for that cost parameters. For example, that maximum limit and minimum limit. Such an analysis can be one of the most interesting and preoccupying areas in optimization. So that analysis increase the efficiency and effectiveness of the decision-making process when they are handling allocation problem. That is, when they are handling that assignment and transportation problem. So this is the mathematical model for the transportation problem. Here we consider M origins and N destinations. the transportation cost of one unit from ith origin to ith destination, we have to represent it by Cij. What is that Cij represents? Transportation cost of one unit from ith origin to jth destination, that we call it as transportation cost. Then what about that Xij? That Xij is the number of units that ship from ith origin to jth destination. Here, Ai represents that supply at a particular point, that supply point I. And Bj represents demand at the demand point J. So here, our aim is to determine the transportation schedule to minimize the total transportation cost, satisfying supply and demand constraints. Yeah. So here, I'll consider that sensitivity analysis of cost in interval transportation problem. So in that, we want to determine the range of cost coefficients in a given interval transportation problem. So I'll share my work that I'll stop this slide, then open next slide. I'll open that next document. Yeah, I think all are able to see the screen. Yeah. Yes, sir.
Yes, ma'am.
I
Yes,
think all
ma'am.
are able. Yeah. Yeah. Here, I'll consider that interval transportation problem. So in that, we want to identify the sensitivity analysis of the given interval cost. For example, here we want to move from origin 1 to destination 1. So here the interval cost is 2, 6. So according to that, we want to move. I'm not able to move the screen. Yeah. So this is okay.
Okay, ma'am. Okay.
Okay. So now I want to split that interval type of transportation problem. I want to split the two types. One is upper bound transportation problem. Another one is lower bound transportation problem. So here I consider that interval transportation problem with interval cost matrix Cij, Dij. Here Cij represents that lower bound limit. That Dij represents that upper cost. So that already we discussed. First part, we want to identify that optimal solution for that given transportation problem. So either using normal method, Modi method, or anyone you can consider. In our research work, we consider that Hungarian method, that 0-point method, bound technique method, like that. So anyone using that Modi method also, you can solve that transportation problem. In that, we identify that optimal solution is this one. So y12 is 20, y13 30, y21 25, y23 5. Then we can identify the Modi indices parameter. So as per that feasible solution, we want to calculate that optimal solution. So according that, we fix the parameters that u1, u2, v1, v2, v3. So then we want to concentrate on sensitivity analysis part. So now to analyze sensitivity of the first part, that is 6, O1 to D1, that cost is, transportation cost is 6. So I want to replace that first cost, that 6 by 6 plus T2. So here I want to calculate the sensitivity ranges for that origin 1 to destination 1. So just here that basic variable, non-basic variables are there. So first, for example, I'll consider that basic variable 6 plus t2. So I'll replace 6 by 6 plus t2. So in that we want to identify that minimum and maximum value for that particular t2. Then we want to add the value for that given cost matrix. So here we found one theorem statement as well as using the condition. I think all are familiar about that condition. Cij minus ui plus vj greater than or equal to 0. According that, we derive the limit. So here I want to replace that first cost by 6 plus t2. First I want to identify a range for the t2. So for that we found one theorem as well as that condition Cij minus ui plus vj greater than or equal to 0. So according that we fix the limit. For example, I'll consider that t2 ranges is from t2 naught to t2 1. Okay, so first we identify the range for that t2. So t2 naught to t2 1. So then that particular limit we want to add for that original cost matrix. So that it will become a dij plus t2 naught, dij plus t2 1. So that represents the range for that cost matrix from origin 1 to destination 1. So in that we concentrate only upper bound transportation problem 1. So in that second part, we want to concentrate on lower bound. So normally we consider 2,6. In that original cost is 2,6. For that upper bound, we identify the limit for that. So similar way, we want to consider a lower bound transportation problem. So in that first we identify the optimal solution for that lower bound problem. Then we fix the mode indices parameter for that. After that, we want to replace the original cost 2 by 2 plus t1. So here in that lower bound transportation problem also we consider that theorem statement. Already we worked it out on that research work, just to go through that. And that theorem as well as that condition that Cij minus ui plus vj greater than or equal to 0, that particular condition. So here that basic variable also there, that non-basic variable also there. Here now I have explained about that only that non-basic variable. So based on the theorem and condition, we are able to identify the limit for the t1. So similarly, I'll consider for the t1 limit as the t1 dash and t2 dash. Yeah, anyone you consider t1 naught and t1 dash also. So according to that, we fix the limit for original cost. So what about the original sensitivity ranges for that given cost? So just you combine the cost for that lower bound and upper bound transportation problem. So in that single bound also we can identify it. But here we consider that interval transportation problem. According that, we identify the ranges for that. So here, for example, I consider cell 1, 1. So for the 2,6, this is your original cost. Okay, so this is your original cost 2,6. For that minimum limit, I'll consider 1, 3, and that maximum limit infinity, infinity. This is only that non-basic variable. Okay, so whenever we identify that non-basic variable, so here that maximum limit we fix that up to infinity. That we have proved that by the. So that transportation cost vary from 1, 3 to infinity, infinity. So like that we can identify basic variable also. So in that basic variable, we proved that separate theorem for that. Here two theorems we have to consider. One is for non-basic variable, that another one is for basic variable. So using these two theorems as well as that condition, we can able to identify that sensitivity ranges for that interval transportation problem. So in that, yeah. Now I'll stop that sharing. I'll open that next one. I think all are able to see the screen. Okay.
Yes, ma'am. Yes, ma'am.
So whenever we consider that sensitivity analysis of cost in interval transportation problem, it provides the critical region of the cost parameters at which any change inside the ranges of the region do not affect the optimal basis. It provides the critical region of the cost parameters at which any change inside the ranges of the region do not affect the optimal basis, while any change outside the ranges will affect the optimal basis. Yeah, wait, sir, I'll change it.
Any problem, ma'am?
Okay, sir. Okay.
Okay, it's moving.
So far we discussed about that ranges for that cost. So whatever given in that cost from origin to destination, we identify the sensitivity ranges for that. So what about the right hand side parameters for that supply and demand? So we can identify the range of right hand side parameters in transportation problem also. So in the transportation, the sensitivity analysis of supply and demand as imprecise parameters. For example, in terms of interval data. So at the time, when we focus on sensitivity analysis, it can assist the managers facing demand or warehouse inventory changes. So it helps the managers who are facing the changes in demand or warehouse inventory. Yes. Okay, sir. Yes, sir. In previous type of transportation problem, we consider only supply and demand. But in the case of solid transportation problem, in the case of solid allocation problem, what about that? So we consider one more factor when we focus that sensitivity analysis in solid allocation problems. We want to focus one more factor, that namely mode of transport. For example, we want to move from one origin to destination, in which we can use different types of transport. Yeah. In that mathematical model of that solid transportation problem, here we consider Cijk x ijk. So here Ai represents quantity of commodity available at the origin I, that Bj represents the quantity required at the destination J, Ek represents the quantity transport by conveyance K. So in that Cijk be the cost of shipping a unit quantity. Cost of shipping a unit quantity from the origin I to the destination J by means of Cape conveyance. So in this also we can able to identify that sensitivity analysis for that cost matrix. So now I'll show the numerical example for that solid transportation problem. So here that origin 1, 2, 3, destination 1, 2, 3, here that supply limit, here the demand point. So for that conveyance, I represent that mode of transport, E1, E2, E3. The capacity 33, 18, 70. So for example, I'll consider the cost 41. We want to move that origin 1 to destination 1. Here I use the transport E1 for that cost 41. So similar way we consider, first we identify that optimal solution. Here in our research work we identified using that 0-point method that is similar to Hungarian algorithm only. That 0-point method, we can identify the optimal solution for that solid transportation problem. Then using that bound technique, we can identify that sensitivity ranges for that cost of solid transportation problem. So now I'll share my screen only that ranges, just you verify it. One minute. So this is for sensitivity ranges for that given solid transportation problem. So here we consider, so yeah, normally we consider when the range is that cost from O1 to D1 means, for example, I'll consider 41. So 41 plus T2. I want to replace that given cost matrix to 41 plus T2. So here the range represents for the T2 alone. Then we want to add for that original cost matrix. Okay. So here the range for that T2 only. So we want to read cost matrix from original cost to that original cost plus T2. Here I given only for the ranges for the T2. So O1 to D1. So for that E1 conveys the mode of transport, that T1 varies from -6 to infinity. Each and every term we consider like that. So after that, we want to add with that original cost. Then we can identify that sensitivity analysis for that given cost of solid transportation problem. Now I'll share that another slide. Wait a minute. Yes. Yeah. This is your original problem. Okay. So just now I'll replace that 41 plus T2. So in that previous slide I given the ranges for T2. Then we want to add with that original cost. Then you will get cost sensitivity analysis for that given solid transportation problem. So here we can identify that right hand side limit also, and that right hand side range also. Whatever we consider supply, demand, capacity, we can able to identify that sensitivity ranges for that right hand side parameters also. Yes. So in that problem, one part is over, that is solid transportation problem. What about that solid assignment problem? So in that first part, we identify that optimal solution of the solid assignment problem. So here, this is the mathematical model for that solid assignment problem. So in that, yeah, Xijk, Cijk represents, already we explained that. Now I'll show the numerical example for that. Yes. Suppose there are 3 men, M1, M2, M3. 3 factors noted by F1, F2, F3. And 3 jobs denoted by J1, J2, J3. So already you know that Cijk is assignment cost of the job J in the factory K to be performed by the man I. So in that M1, M2, M3, F1, F2, F3, J1, J2, J3. 3 factors given. So in that normal assignment assignment problems, only we concentrate on 2 factors. But whenever we focus on that solid assignment problem, here we want to concentrate on 3 factors. So according that, we fix the cost value. So here, our aim is to determine the assignment of jobs to at minimal cost. Then we identify the cost sensitivity analysis for the given solid assignment problem. Yeah, now I will share my another screen. Yes, the last one. This is not FDP, SAP. Okay. So sensitivity ranges for that given solid assignment problem. So here we consider that origin 1 to destination 1, that E1. Yeah. According that, we can identify the sensitivity ranges for that given solid assignment problem. So here also we want to replace the cost by that Cij plus T2. So here I given only for ranges for that T2 only. Then we want to add with that cost coefficients. You'll get that cost sensitivity ranges for that given solid assignment problem. Yes. Yeah. Here there is no right hand side parameters. Okay. So for that assignment problem, simply we consider that we want to assign one job to one worker. According that, we can identify the minimal cost for that. So it will help the decision maker to take an appropriate action that while handling various types of allocation problem having 3 parameters. Okay. So in our research work, so we use that solid assignment problem, solid transportation problem, and that fuzzy problem, that fractional assignment problem, like that. So in future, one who can extend to analyze that sensitivity in various type of allocation. For example, bottleneck allocation problems, solid fixed charge transportation problems, that multi-criteria assignment problems, generalized allocation problems, and 2-stage allocation problems. Yes. Selvamani sir, is there any doubt?
Hello, ma'am. I'm calling from Bangalore. My name is Rupa. How your initialize values you are taken? Some problem you told 1,3, some problem 41 like that. How we have to initialize?
Yeah,
ma'am?
we consider the data, ma'am. It is not industry data like that. We consider some random data only.
Suppose I'm going to take some different value in the initial value. Maybe we get different approximate, right, ma'am?
Yeah, yes, ma'am. Yes, ma'am.
Okay. Well, based on the required accuracy, you are going to initialize the values, ma'am?
Yeah, yes, ma'am. Yes, ma'am.
Thank you, ma'am.
Kavita, ma'am?
Sir?
Yeah, is it over, ma'am? Is it over or you are going to continue?
Yeah, over, sir. Is if you want to give more examples, I'll show it.
Yeah, 30 minutes more, ma'am. We can do any other.
Yeah, okay, sir. I'll share any other slide. Can I share any other slide? Yeah, wait, sir. 2 minutes, wait. I'll share my document.
Excuse me, ma'am.
Yeah,
Why
yes,
don't you explain one problem, how to take that each step? Suppose they don't know the transportation thing.
Yeah.
Then
I'll explain. Ma'am, now I'll explain.
Thank you, ma'am.
Okay.
Excuse me, madam.
Yeah, sir.
How do you categorize the data, madam? Assignment model?
Yeah, data is that normally we take random data only, sir. Not at all industry data, not at all that medical data. That random data we consider, that's it.
So we can apply for this COVID-19 data also, madam, this model?
Yeah, this is particularly sensitivity and specificity. In
Okay.
that, we want to consider that errors, in that chi-square test, we can amplify that particular portion.
Okay, thank you, madam. Thank you.
Okay, sir. Yeah, in that one more example, I'll give that. Yeah, wait 1 minute.
Dear participants, if you have any further question, you can post it on the chat box.
The chat box is not taking our questions, sir. It's not moving.
It's moving, ma'am. Already check it now.
In my chat box, they showing that privately.
1 minute, ma'am. Now you can ask the question on chat box, ma'am. It is enabled to everybody.
Yes, madam, all are able to see the screen?
Yeah, yes, ma'am. Yes, ma'am.
Okay, sir, okay. Yeah. So, ma'am asking that one problem elaborately. Yeah, I'll consider that same problem only, okay? So, here, consider that 2 plus t1, that is a non-basic variable 1, comma 1. So, according to the condition, we consider that Cij minus ui plus vj greater than or equal to 0. So, what about here Cij? So, that 2 plus t1
இப்போ மியூட் பண்ணிட்டேன்.
See, there is going to be ad is doing a new thing. Here, let me silly, give your dear something. Never smile with your eyes and laugh with your nose. You could try it out and see how it goes. Try walking on your hands, writing with your or liners, have your breakfast at night. Socks. Comb your hair with a spoon. Doing new things can be so much.
minus 1 to infinity. So we proved that. What about that upper limit infinity means? According to that theorem statement, we consider that upper limit for that non-basic variable. Similarly, so in that basic variable, what about the lower limit? That also we proved in that statement. So just you go through that sensitivity analysis in allocation problems that many articles found on that Google Path. Just you check it out. As per that theorem statement, we consider the limit. So then
I asked you, I read it 2 times. 2 times, did I read it the same way or did I read it in a different way? Yes, Reena.
And that T1 is from -1 to infinity. Then we want to add that particular limit to that original cost. Then you will get that sensitivity ranges for that given cost. So here already we discussed 6 plus T2. So similarly, we fix that condition C11 minus U1 plus V1 greater than or equal to 0. According that, we want to identify the limit for T2. That is -3 to infinity. The ranges for T2, this is T2 ranges only. Then we want to add to that original cost. Then only you will get that original cost sensitivity for that given problem. Okay. So similarly, we identify that basic variable also. Yeah, that basic variable, I'll explain it now. Yeah. So in that 1, 2, the old letters, that 20, 30,
Yes,
5 variables, we call it as basic variable. The 2 and 3, we call it as non-basic variable. So in that basic variable, how to identify the sensitivity ranges. For example, here I'll consider the cost 3 plus T1, that corresponding U1 value as 0, that V2 value as 3 plus T1. So for that, here I want to identify that limit T1 varies from minus infinity to 0. So here minus infinity is not possible whenever we focus that cost coefficient. So instead of that, I'll consider that is 0 to 3. When we define the ranges, we want to focus that. So negative cost, we are not able to identify in that particular problem. So according that, we fix for that basic variable, the lower limit as 0. So whenever we focus that non-basic variable, we fix that upper limit as infinity. Whenever we focus that basic variable, we fix that lower limit as 0. This is for that cost coefficient for that basic variable. So similarly, we can identify the remaining value also. So once you go through the theorem statement and condition, you can able to identify that sensitivity ranges for that remaining values also. Yes, sir. Yeah, after over that, we can identify finally that sensitivity ranges for that interval transportation problem. Yeah, already I showed that this one. So for example, this is the original cost. So 2, 6. So for that, we want to identify that minimum limit, maximum limit. So this variable as a non-basic variable. So what about that basic variable? So basic variable Sir, all are able to hear my voice?
Okay, ma'am. Now is okay.
Yeah,
Before
yes,
that,
yes.
we are not.
Yes, ma'am. Yes. Okay, ma'am. Okay. So similarly, we can identify either in that fractional assignment problem, solid assignment problem, that the solid transportation problem. We can identify the sensitivity ranges for that each and every cost. So for example, we consider supply, demand, conveyances. In that also we prove theorem statement as well as that procedure, how to identify that ranges for that right hand side parameters also. For example, for that, whenever we consider supply, what is the ranges for that supply? So whenever we consider the demand point, what is the demand ranges for that? So like that we can identify. Just on that Google, just you type it, that the sensitivity analysis for transportation problem or allocation problem or assignment problem. Simply you can identify the different types of transportation problem and allocation problem. You'll get that sensitivity ranges for that. Is there any doubt, ma'am, sir? Sir,
Yeah, ma'am.
is there any doubt, sir, in between?
They're asking, ma'am.
Oh, okay.
Ma'am, this transportation the thing is possible to apply in weather prediction, rainfall data there?
Weather prediction, yeah, we want to convert into we want to move one place to another place. Like that, we need a table, ma'am. Then only here we consider only that the mode indices parameter. Na? So according to first, we want to frame the table. Then we identify the mode indices parameter. Then we can able to identify, but it is not possible or not in the weather prediction. That I am not idea about that one, sir.
Yeah, moving one place to one place instead of moving one place to one place is possible to take for season.
Yeah.
Huh?
Yes, ma'am. Yes, ma'am. In that assignment problem, we consider like that only. We want to allocate one job to one worker. So according to that, we can identify it. No problem.
Oh, yeah. Okay.
Any other questions, participants? If you don't have any further question, we can come to the conclusion.
And also, please tell me what are the applications. So you are telling one application. Is any other application based on this transportation useful in any?
Yeah, yes, ma'am. In that network, wireless network, that pipeline network, that lineman, that power network. So in that we can identify that network we convert into in terms of transportation problem. From that we can analyze the sensitivity of partner. Wherever the network working at the time, we can convert it into transportation problem. We can easily identify the sensitivity ranges for that each and every network base.
Thank you, ma'am.
Okay, ma'am.
Any other question, please? Okay, ma'am. Kavita, ma'am, can you conclude now?
Yes, sir. So I'd like to end my presentation. Thank you, Professor Salman, sir, given a chance to lecture for that FDP online session. Thank you, sir.
Thank you, ma'am. It is a clear and informative session to all, ma'am. Thank you once again. Thank you once again for your acceptance among the chaotic pandemic situation. Thank you, ma'am.
Thank you, sir. Thank you.
Audience, please post your attendance and feedback on the chat box. This in the chat box. Audience, please put your attendance and fill the feedback. It is in the chat box. Kavita, ma'am, you can leave now.
Oh, okay, sir. Thank you, sir.
Thank you so much, ma'am. You can unmute now.
Sir, they asking through mail. We want to fill the feedback form, sir.
No, ma'am. It is displayed on the chat box. Please look at the chat box.
No, is there, sir? I know, sir. Once you click that, he's showing that is abuse. Sign in, and then you have to fill the form. That's the way they're showing that. If you want to check it, sir.
Okay. Thank you, ma'am. Thank you. Once again, I will check it.